So we are officially on day 4 of geometry. And today is, what is it, Thursday now? Yeah, Thursday. It is December 11th. 14 days till Christmas. If you're counting. It's coming quick, guys.
Yeah, it really is.
I know. I need to get presents still. So I need to do
I'll
that
be glad
soon.
whenever it's over.
Yeah. Well, my fiance is a Grinch, so he barely let me put up a Christmas tree. Anyway, let's look at our do now. We have the first part says describe each type of angle below and then draw and label an example of each. So I gave you the 3 types here, except for I didn't include the straight or flat angle. Just the 3 most common angles here. So does anybody know how we could describe an acute angle?
Less than 90 degrees.
Yes, perfect. An acute angle is any angle that is less than 90 degrees. So if you didn't have that yet, let's write that in. Less than or smaller than 90 degrees. And if you don't have a protractor out already, that's this. Let's grab one of these and make sure that we can draw an acute angle. So an angle is made up of 2 rays. I'm going to start with a ray. I'm going to use this as a straight edge. Ray down here. And if I'm using a protractor to draw or measure an angle, where should I line my circle on my protractor? Yeah, we want to line that hole with my point right here. And we want to make sure it's laying nice and flat on there. And we said less than 90, so here's 90. Would I go this way or that way? Yeah, I'm going to go to the right because we can see if this is my starting ray, I'm going 0 degrees, 10 degrees, 20 degrees, 30 degrees, 40, 50, 60, 70, 80, 90. So if it's less than 90, you could pick any measure that's over on this side. I'm going to go with 40. Yeah. So I'll just put a little point on 40 and I will connect. There we go. So there's my acute angle. If you didn't draw a 40-degree angle, that is fine. It could be anything that's less than 90. And so if we wanted to label this, something else we could do is put a little arc in here and just write the degrees. So I'm going to say 40 degrees was mine. Yours might be different, but as long as it's less than 90, you're good. There's our acute angle. How could we describe a right angle? 90 degrees. Exactly 90 degrees. Exactly 90 degrees. And so we'll do the same thing, starting with a ray on the bottom. And the point. That hole on the vertex. And 90 is straight up and down, just like that. So I'll put a little mark there. And I will use that as a guideline. I trace down to my point. And that is an example of a 90-degree angle. Now, a 90-degree angle is special in the way that we label it.
Your little box.
My little box. Good. 90-degree angle always gets a box. It's a little square. Okay. Good. Last angle, obtuse angle. How do we describe that?
More than 90.
More than 90 degrees. Good. More or greater than. More than 90 degrees. Now this one might be a little bit trickier to draw in such a small box.
Because I went a little outside the box.
Yeah, you might end up going outside the box a little bit, and that's okay. But what we can do is, I know that since it's gonna be bigger than 90, my angle is gonna end up tilting left. So I don't want to start my point all the way here, or it's gonna go over that way. I'm gonna start my point about here in the middle. And draw a ray. And then as long as, which one did you say one more time? 110, so 110, we could do that. I'm gonna do that. So here's 110, that's more than 90, I'll put a little mark. And we can draw a line there. And I'll label this with an arc and write 110 degrees, just as an example. Now notice I didn't write 90 next to the box. Whenever you have a 90-degree angle, that box always means 90, so you don't necessarily have to write 90. But you can. You wouldn't get it wrong if you did. So here are some examples of those 3 angle types. Now just for fun, what would a straight angle be described as, or a flat angle?
180 degrees.
180 degrees. So if we want to write that to the side as a bonus, so extra, a straight flat angle is exactly 180 degrees. And what does that angle look like?
Just a flat line.
Just a flat line, exactly. And we can see that on our protractor. If I were to go all the way over to the other side, it only goes up to 170, but we know that there's 10 more spaces over, so 180 would be right there, giving us a flat line or a straight line. That one's pretty easy to draw, just like that. And if we wanted to label this one our arc, which is like what I put next to 40, next to 110, the arc of a flat angle or a straight angle looks like a half circle. And then I'll write 180 degrees. So if you find room on your paper, that's a good little note to take, just as a reminder. So that's the first part of our do now. Okay. Now let's shift our paper down, unless does anybody still need to see any of this before we move on? Anyone? Hello, hello. Sure, a lot of people in here. So now we're gonna go to number 2. And this is where we do some constructions. So it says, using a compass and a ruler, construct the perpendicular bisector and the angle bisector of the line segment and angle below. So again, your compass looks like this. Make sure you've got one of these. And if your compass, again, we talked about it yesterday, if whenever you pull on it, it opens up really easily, go ahead up to the front of the room and grab one that's a little more stiff. It's really tough to use one that is loose. You're going to want one that holds its shape really well. So I'll wait a second and make sure everybody's got one of those. And whenever we do these constructions, I passed out a construction guide yesterday, and each of you should have one of these. If you do not and you need one, let me know. I have extra copies up here. But looking at that guide, let's start with the perpendicular bisector. Showing my first step is that I have a line, but really this is kind of my first step. Where does the point of my compass go first?
On the dot.
On one of the dots. Good. Doesn't really matter which you start with. Because I'm right-handed, I'm going to start on the right dot. Just going to put it there. And does it matter how big it's open?
Yes, over halfway.
Yes, it needs to be over halfway. So if I had it open this big, that's too small. If I have it open this big, well, technically this would still work. You're just going to have really big arcs. I like to do it just a little bit more than half so I don't take up too much space. So I'll do it about there. And then we're going to create an arc like this. If you're struggling to move it, you can move your paper instead. And oops, I lost my spot. You want to put most of the pressure on the metal. The trick here is try not to touch the pencil. Hold it by the metal piece and rotate your paper. Let the pencil kind of lightly drag on your paper and really put your pressure on that point.
You move.
I keep moving that thing, man. See, I know it's tricky. Okay, so here's a great big arc, kind of like a half circle going in. Now, I don't actually need all of that, but having more is better than not having enough. So once I've done this arc, what should I do next?
Go to the other dot.
Go to the other dot. Now, if you have a hard time switching and using your other hand, don't do that. Keep it in whatever hand you write better with, and you can just flip your paper upside down. If that's easier, do it that way. I'm going to hold it just touching the metal like that. Put my point down and really hold it steady. And we could do a whole nother big arc, but all I need is the intersections of the arcs. So if I want, I could just mark here and rotate, mark here. Now, just to show what it looks like, you can do the whole arc again. Just know that we only need the X's that we make, the intersections. Now, from one arc to the other, your compass needs to be open the same size. So if you just made one arc and then you measure with your compass to the other and they're not the same size, you may want to redo that arc. Okay, so I'm going to flip my paper back around, and this is what we should end up with.
What'd you say? Sorry.
I don't even remember what I just said. What did I just say?
Draw your line.
Okay, yeah, let's draw our line. This is what we do in the last step. These intersections are our guides. All we do now is use a straight edge of some sort, and we just trace through those points we made. There you go. Now we've split our line segment perfectly in half at a 90-degree angle.
Don't you need to draw your box?
I do.
The other lines?
Yes. I need to draw a box to show it's 90 degrees. And I need tick marks. What do these tick marks show me?
That both sides are equal.
That both sides are equal. Yes. You do use lots of little markings to show that. Good. So I'm going to show that one more time on the back of my paper, just to make sure we've got it. Good morning. We are working on our do now. Got some copies up here for you whenever you're ready. I'm going to show that one more time. So I'm just going to draw a second line segment on the back. And demonstrate again. So here's my line segment. hold your compass by the metal. Point goes on the point, and we make an arc. Flip it around. Point goes on the point, and we make another arc. There's my intersection. And we connect the dots. So it's arc, arc, line. And then we label with our box and our tick marks. Okay. Does anybody need to see that a third time? Or are we getting it? How are we doing with these? Might need to see it again. That is totally fine. This is not an easy thing to do. These compasses are kind of tricky. So I'm going to draw one more line segment. And again, if you're holding your compass like a pencil, it's going to be a little harder. I promise you it's easier if you're just holding the metal. Just hold the metal. Because if you're holding the pencil, you're going to end up accidentally moving something. We want all the pressure on the point. And then if you're scared to move your hand, move your paper instead. And don't let the point move. Go all the way. You could even rotate all the way around the other way if you want. You could do a whole circle if it makes you feel better. Okay, so there's one. Before I go to the next point, make sure my compass hasn't changed. It's still open to the same size. I'm going to just turn my paper over so I don't have to move my hand. Point on the other point and rotate around again. You could do a whole circle if you want. Again. There you go. And look, we still get the intersections. We still get those. So I'm just going to trace the line through where those arcs cross. Okay. And then we show it's 90 degrees. And the line segments are equal. Got it?
Question, Ms. Taylor.
Yes.
Can you kind of explain the difference of the perpendicular bisector and the angle bisector?
Yes, absolutely. So one of the main differences in the perpendicular bisector and the angle bisector is the perpendicular bisector, you're only making two arcs. And it's just from 2 points that already exist. So let me show that one more time, for the third time. Perpendicular, we start with a line. And we can remember that anytime you see a point, that's where your point's going to go. So there's 2 points. I'm going to make 2 arcs. So let me get that on there.
Oh, okay. And the angle part is where you drew the 90-degree
Yeah.
angle between. Right.
Yeah. So here's an arc. On my other point, 2 arcs. So for a line, we just do 2 arcs, and then we draw a line going through. Perpendicular means 90 degrees, so we do the box. And bisector means we cut it in half.
Yeah.
So we put the tick marks to show it's same size. So if we wanted to put a little note on here, let's see. Perpendicular bisector is 2 arcs. And then we do our line. For the angle bisector, we actually have to make 3 arcs So let's start our angle bisector. And I have this labeled as a 45-degree angle. We still want to make another first arc here. This might not be a perfect arc. Maybe it is. I'm not sure. I could check. See. Making it a little bigger. So just like we start on a point for the perpendicular bisector, for the angle bisector, where does my point begin?
Vertex.
On the vertex. This is the only point I have on my angle. So this point is where my point goes. And do I have to be as picky about how big my compass is open here? No, I don't. Yeah, for the angle bisector, we don't have to be as picky. I just like to put it somewhere in the middle-ish. It's okay if it's bigger, it's okay if it's smaller.
Just make, like, for the one before that you just did,
Yes.
is it just making the circles big enough so that they actually
Yes.
loop?
Yes, ma'am. So for the first one, perpendicular, the circles and the arcs have to be big enough that they actually touch each other.
But this one, it's like,
For this one, this arc is its own thing. So it doesn't necessarily matter. However, if you make it so gigantic that it goes off your page, that won't work. If you make it so tiny that it's hard to work with, that's going to be tricky too. So just make it a size that feels comfortable. I'm going to keep it about this size. And this arc needs to pass through both of the rays. Just like we're literally drawing an arc inside an angle, like that. So again, point on the point.
Okay.
And yes, on the vertex, thank you. Point on the vertex.
corrector Diane, there you
And
go.
if you're better with your right hand, turn your
Yeah.
paper upside down. Don't be scared to move your paper around. I'm gonna hold it by the metal.
count that as number
Make sure that point does not move. If you need to instead, move your paper. And get an arc. That's your first arc there.
first arc.
A first arc. So this is arc number 1. Number 1. Right here. And now that we've used the vertex, we have our first arc. We just created 2 intersections, didn't we? There's 2 spots where that arc crosses, right? So just like with our perpendicular bisector, once we create intersections, these are like points that we're going to use for future steps. So this is a point here. My point goes on the point. Okay. Now, if it's easier to not close your compass anymore, just keep it where it is. And we just want to make our second arc inside the angle. So I'm going to just start here and move my paper inside the angle. See that? So that was my second arc. And I'm going to mark the point I used and that arc. So I used this point. What am I going to use to make arc number 3? The top intersection. Good. So my point goes on the point. And again, if it's easier to flip your paper around, do that. I'm going to flip mine around, put my point on that point. And again, arc goes inside the angle. And we want it to cross the second arc. Look at that.
What is that called?
What is
The third point.
the third point here?
Yeah.
Just the intersection. Intersections, yeah. So anytime your arcs cross, or even when lines cross, those are intersections. Intersections. They cross. So that was arc number 3. And I'll label that. We started with our point here on this intersection, and we made arc number 3. I'll mark arc number 1. This one we used the vertex to start. Go. And I've done all 3 arcs now. So what's my last step?
Draw a line through the last intersection?
Yes, draw a line that goes from the vertex through the last intersection here. So this is like your final point, the final intersection. And we're going to put a ruler there. Draw a line going through. Good, good. And we've done it.
That's it?
That's it.
See, I think that's what's throwing me off, because things that are like not, this is not simple, but it's like kind of simple. Like it's just some lines, but my brain is like, something's not.
But you know, I think yesterday, by the time we got to constructions, we had done a ton of work. And sometimes it just takes another day of practicing for it to click. And we'll do some more practice with this. Does anybody need to see or want to see this process done one more time? We can do it a few more times. I'm gonna leave this up for just a second while people label. And then I'll probably draw a few more angles that we can practice with. But I'll trace through the steps again. Step 1, point on the vertex, make an arc inside the angle. And the key is all of your arcs are inside your angle. Inside the angle. That first arc gives us 2 more points, 2 intersections. Next, your point goes on one of those intersections. We make arc number 2. Point goes on the other intersection. Arc number 3. And then that intersection from the last 2 arcs is where we draw the bisector. And we split our angle in half. Okay. And how can I show that I split my angle equally? A little jujutsu. Yeah, my little jujutsu, my little arc. Arc. I can do that, or I can do 2 arcs if I want. That just shows this angle equals that angle. Oh, very nice. I'm gonna flip my paper over. I'm gonna show that one more time with a fresh angle. Flip it over. And on the back right here, I am gonna draw another 45-degree angle.
Yeah, I'll make sure that I don't want to put you back.
Okay, so I'm gonna start with a ray. And a point for my vertex. And I want 45 degrees. So we're gonna mark in between 40 and 50. That's about 45. And then draw the other ray of my angle. So here is my angle. Okay. So I just made a 45-degree angle here. Same as on the front. And what do I do first?
You put your point on the vertex.
Point on the vertex. I'm gonna flip my page because I'm right-handed. It's gonna be a little easier if I have my pencil inside the angle facing this way. If you're left-handed, it might be easier the other way. And my arc should go inside the angle. So, inside. It's okay if it goes outside a little. In fact, it should, so that you can see where it crosses. So that was arc number 1. I just made sure I made an arc in my angle. Okay. Now what?
You put your point on the other 2 points you just made.
Yeah, we just made 2 more points. We made 2 intersections. So I'm going to pick one of those, put my point on that point, and make an arc inside my angle again. Inside. The other point for my third arc, point on the intersection, and a third arc crossing that second arc. There we go. And last but not least, connect the vertex to that last intersection. We got it. I'll flip that around and mark that my angle equals. Go. Okay, now if any of you are still kind of struggling with these, because I know they can be tricky, whenever we have extra time today, I can definitely give you some extra practice with this. I can make as many of these practice sheets as you need. If you need to borrow one of these, you can absolutely do that. Before we do move on today, does anybody have anything with these constructions that you feel like might be giving you the most trouble? Or has anyone maybe discovered a trick that helps them whenever you guys are doing these? Is there anything that feels hard or anything that might help make it easier?
I just stick with using the colors.
Stick with using the colors. Yeah, colors, I like doing colors. Color coding helps me. So I'll color code this one too. I'm going to use my point and match it to the arc. Same color. That was 1. Pick another color, match it to 2. So maybe I do this point goes to this arc. Do a third one with that third intersection and the third. Something else that might help, just to see where the arcs come from in regards to the points. If you want to draw whole circles for these, you can do that. So if I were to put my point here, instead of just drawing an arc, I could trace all the way around and I'm still getting the marks I need. See, I'm just using part of the circle there. And then for my second one, I'm still using that arc, but if I want, I could just circle it all the way around. But you see, I'm just using the blue part of that circle. And then for the third arc, I'm just using the purple part, but if I want, I could make a full circle.
So we're always using a point from the first one?
From the first one, you like right here?
the first arc. So we do the point from the vortex.
Yes.
And then we move on to do that circle. And then our second one is the bottom one, and then the third one is the top of that.
Yes. Now you could do top first, then bottom. That won't matter.
Okay.
But basically the order is make an arc off of the vertex, and then that arc that we make for step 1 gives us 2 more points.
So that's like the layout for the plan.
Yeah,
Pretty
yeah.
much. Okay.
Exactly. So if it also helps to see that like this is start for 1, and then that's where the arc happens. And then start for 2 is here, and that's where the arc happens.
I'm never missing days again. Ridiculous. I'm be back here dying before I miss another day.
Get home like, oh my God,
Yeah,
I'm
dang.
so confused. It's not even funny.
Bro, I feel like I'm listening to a foreign language, but it's alright.
Heather's gonna get us right. It's fine.
I'll get you guys.
Yeah.
So how about this? Let's have like an open conversation about what's feeling like the foreign language. What's confusing us, right? What are we lost on?
I think I personally just need to go back through the notes because I missed days and
Okay.
do more
Watch the
practice.
videos. And,
Yeah, do more
Gotcha.
practice stuff.
Okay, I get you.
Practice will help a lot.
Yes. All right. Well, if there's anything that I can help with today, luckily today is our quarter day. So as you and anyone else is getting caught up, hopefully we're going to be feeling really good today. So,
Ms. Patton,
yes.
Step 4 will be the line that's going. through,
Yes.
uh,
Thank you. Step
Plus-
4 is the line.
Plus the 2 arches.
Yes, and these
Okay.
little, yes, you're right. So step 4 is that line that goes through. And the little arcs that shows these are equal. Good. And constructions are one of those things that you just have to practice it. You just gotta do it a bunch. You gotta do it a whole bunch. And I will have some papers with plenty of practice for us on these. So, I'm gonna try something. Let me move this up for a second, and I'm gonna create something for you all. All right, guys. So let's put this to the side. Keep this somewhere safe, maybe in your notebook. And we are gonna pull out our notebooks and take a few notes. If I can give any reassurance here, we're actually getting very close to the end of Unit 1. There's not too much more that we're gonna do for this unit. So let's see, moving on to. So there was our perpendicular bisector. If anybody needs to see these notes, if you were missing a certain day, just always come and ask me after class. I can make you copies. I can let you see my notebook, all of those things. So we are on day 4 of our notes, and I'm going to title my notebook with that. Um, Page 1 today. And we're going to do some slightly more mathy things today. We've talked a lot about angles And we did some practice with the parallel lines and angle relationships. But now we're going to talk more so about angles specifically and solving for x with different types of angles. So I'm going to title this Solving for x with angle. What we're going to do after we write that title is we are going to draw a straight line. And I'm going to make that straight line about 3 inches long and about 2 inches away from the title. So 2 inches down the page, 3 inches long. So, draw a 3-inch line here. Stop. Put arrows on the ends. And if you can find about the middle of the line, if it's 3 inches, the middle should be right in between 1 and 2 at 1.5. And we're going to put a point there in the middle. Now, how many degrees is this if it was an angle?
180.
180. Perfect. This is 180 degrees. It's a straight angle. So what we're going to do now is we're going to split this angle. I am going to take my protractor. And let's find about roughly 60. Doesn't have to be perfect because we're going to pretend that we don't know it's about 60. Try my best to 60. Yes. So I'll mark this. I'm going to say this angle is 60 degrees. And we'll put an arc. Now the other angle that we've created, we're going to split that in a random spot. I don't want to know what the measures are. Let's put it, I'm going to make it kind of smaller. And we'll just draw a line this way. I don't know how many degrees these are. I don't know. I'm just guessing. So we should have 1, 2, 3 angles total. One is labeled 60 degrees. I'm going to label this one, the smaller angle down here, as 2x. And then this angle, the larger one, let's make it 3x plus 1. We don't have to put arcs in there. But if you wanted to show that we don't know if these are equal, I used 1 arc for 60. I need to use a different number for another angle. So maybe I'll do 2 arcs there. And maybe I'll do 3 arcs on the third one. two. So 3 different angles. Three different angles. It's okay if it's not perfect. And remind me, what is the total degrees of this big angle? 180. So I'm going to put here equals 180. Okay. Now, above each of these angles, I'm going to put some letter names. I'm going to say this is A next to 2x. Above 3x plus 1, we'll call it B. And by 60, we'll call it C. I know that the whole thing is 180 degrees. So what we can do with this picture, without using the values, just using ABC, is we could write an equation that would be A plus B plus C equals 180, right? Once I have this, can anybody guess how I could use all of this information to write an equation and solve for x? 2x plus, you're right, b is 3x plus 1 plus c is 60 equals 180. So you see what we just did there? We just took a crazy picture and we turned it into an equation. We can solve for x this way. So I'm going to let everybody get caught up to there. You know, when we have pictures in our notes, it can take a little longer. So when we're ready to solve it, give me like a thumbs up. Do this when you're ready. Amber's ready. Anna's ready. Anna's ready. Ty's ready. Percy's ready. Candace is ready.
It's possible to have number decimal.
Yes, you'll probably get a decimal on this one. Because I just gave you random numbers. So usually when I give you random numbers, I don't give you a pretty answer. See a few people still writing. Charles, is ready?
No.
You're ready. Okay. Let's go ahead and start solving this equation. If it helps. Oh, yes, by the way, if you do not have a calculator yet, let's go get one. Diane is being incredible and passing some out right now. Thank you. Does anybody still not have a calculator? Everybody got one? Okay, good. All right, so I'm going to put a line through my equal sign. Whenever I have a great big equation like this, what is a good... Doesn't work? Where? Beauty. Okay, let me erase this real fast. Sorry, guys. Okay, so I'm gonna repeat myself. With a great big equation like this, we have lots of plus signs and different numbers and things. What's a good first step for combine lines? Yes. Let's combine like terms. What like terms do I have? 2x and 3x will give me 5x. Plus, yes, 60 and 1 gives me 61. Equals 180. Yes, now we can subtract 61 on both sides. Minus 61. Minus 61. 180 minus 61 is 119. Bring down equals. Bring down 5x.
Divide 5.
Good. Divide 5.
103.8.
And
Equals X
yes.
43.8.
Good. X is 23.8. We do get a decimal, and that's okay. Good. There is a decimal. 23.8. On, say it one more time. I'm so sorry. My hearing is awful.
The decimal.
The decimal?
Yeah, on the exam.
On the exam, well, if there is a decimal, I will tell you in advance because I know we second guess ourselves. I will let you know if there's decimals on a quiz. I will. I will tell you. Okay, so I found X. Now, question. If this is my X value, can we figure out what angle A is and what angle B is?
Yeah, you can plug it in.
I can plug it in, can't I? So I'm going to write to the side.
Yeah.
Angle A. Now, remember there is a symbol we use so we don't have to write out the word angle. So angle A is 2x. What is angle B?
3x+1.
Yes, it's 3x plus 1. And Amber, you said we can just plug that 23.8 in. That's correct. So let's find angle A first. 2 times x.
5.
So 2 times x is 23.8. And what do we get when we do that?
47.6.
47.6. Okay, so angle A is 47.6 degrees. All right.
Wow.
Wow.
I want to build a house. This is not.
I know this. Yeah. Okay, so how do I find angle B?
3x plus
3 instead of x.
-3.
22.8 plus 1. Okay, so 3 times 23.8.
71.
That's 71.4 plus 1. That's 72.4 degrees for angle B. Good. We did it. And if we did it right, angle A plus angle B plus angle C has to be equal to 180. Right? 180. So let's check. A was 47.6 plus B was 72.4. What's angle C? 60. And when we add those together, we should get 180. Let's check. 47.6 plus 72.4 plus 60. Look at that. It worked. We did it.
At least with math, you can like check your work.
Yes.
You can't really check your work on like in history.
Right. The math, you can check your work. That helps. That definitely helps. Good. Okay. Thank you guys. Very good job. Right. Well, I'm going to say it is 10:20. So, it's about break time for us. Let's take a 15-minute break here, and then whenever we come back, we are going to do just a teensy bit more practice with this, and then I'm going to get you guys out of here early today. So, take a break. We'll be back at 10:35.
Hi, Charles.
So, we're back from our break, And we just did this little page of notes. We solved for x with some angles that were on a straight line, 180 degrees. And I just passed out a worksheet with some things we haven't talked about. So I just want to address a few of the things that we see on this paper. Number 1 and number 6. We have something funny going on.
A whole lot of funny.
They got a circle on the outside.
Yeah, there's a circle on the outside. So normally when we have an arc, it's telling me how big the angle is opening. So if an arc is on the inside of an angle, it's saying it only opens that large. But what do we think it might mean if the arc is on the outside?
They can open more.
It can open more. Yeah. So what this means is this angle that's labeled as x degrees is so big that it's opened all the way around, not just 180 degrees, but more, all the way around that way. So it's
360.
360. Oh my gosh. Okay, so before we start doing this, let's flip the page on our notes and take a note of that.
Okay.
So day 4 notes continue. And let's make sure we understand all the different things we can see with angles. Give ourselves a little guide. Take 2. Why I wrote you 5. That was an accident.
It's muscle memory from
I guess.
when you're doing the equations.
Got it. Oh, okay. So we know that when we have, let's put a little point here in the middle. And let's draw a straight line. All the way across the page here.
Okay.
And then this doesn't have to be perfect unless, you know what, let's actually make it a little more, let's be accurate. I'm going to use my protractor. And I want, once I've made my straight line, I want to mark a 90-degree angle. So let's line it up and mark about 90. And I want to draw a line going all the way through so that we have like a big cross on our page. Almost like you just did the perpendicular bisector, but we don't have to construct it. Let's do this. And I'm going to start with a box for my first 90 degrees. And then I'm going to pick a different color, maybe blue. So there's my 90. And now I'm going to make a half circle for my 180 degrees. So there's a 180-degree angle. And then I'll pick a third color. And we're going to draw a great big circle all the way around to show that this is 360 degrees. So an angle that starts here, opens up all the way around, and ends here It's 360 degrees. It's a full circle. It's a full circle. So when we look at this and compare it to number 1, we can see that there is a 27-degree angle right here. And we can see that that's part of the arc. And then it continues all the way around and stops back at the other side of that 27-degree angle. So if 27 was, let's call it angle A, and let's call X angle B. Couldn't I write the equation A plus B equals 360?
Yeah, you.
Yeah, I could.
Yeah.
So let's write A plus B equals 360.
All right.
All right.
I think we're gonna put 27 plus B equal to 60.
You're right. We are. You're exactly right. We can solve for X by plugging in these values.
Hello.
So here we go. Here we go. So, Mia, repeat what you said. Tell me, what should I write to find X?
I say 27 plus B equal to 16.
Perfect.
You got 260 minus 27.
Good. So let me write that. 27 is our A.
Okay.
I replaced A with 27 plus B, that's our X. So I'm actually going to write plus X equals 360. And can I zoom in on this and move this
B is
picture?
360.
Can I move this?
But no.
A equals X.
X is B.
In this situation.
Yeah, B is our X.
Yeah.
So that's why I replaced A with 27.
Mm-hmm.
I replaced B with X.
Yeah.
And 360 is the same. Okay, I'm going to scoot this over. Let me know if anybody needs to see it again. I'm going to zoom in. Okay, so all we got to do to solve it is get X by itself.
Yes.
Yeah, subtract 27.
Oh, so smart.
Look at that. X equals 200. Say it again.
333.
Oh, I'm wrong. 333.
Yeah.
Angle number.
Beautiful. Okay, 333 degrees. And that's it. We did it. Now that looks scary, but that's not so bad. Huh.
That part ain't.
Right.
That
Once you
part.
understand it, it's not that bad.
It's a puzzle.
It is. It is a puzzle. Good. Good. So we just solved number 1 in like 2 seconds.
Can we jump to number 6? Since
Yes.
there's a
Yes.
3 different numbers and a 90-degree angle.
Absolutely.
Six.
Let's jump to number 6.
Yeah.
So, for number 6, we have a couple of options to solve for X. We could use the whole 360 degrees and say this angle plus that angle plus 270 is 360. Or we have something else given to us.
You could, instead of doing the x minus 174 and 28, you could use 90.
Yes. Yes. So keep in mind,
Yeah.
when we
Well,
see
that's
a
acceptable.
square, a box, this means 90 degrees. These two angles make 90, don't they?
Yes.
I said it looked confusing.
That dude though, for real.
This is 90 degrees. So we have two options. We could write a shorter equation and just use x minus 174 plus 28 equals 90. Let's write that. I'm going to use a red pen for this. X minus 174 plus 28 equals 90 degrees. We know that because of the box. Okay. And let's solve this one first. So now that I have an equation written, how do I solve?
Alright.
Like terms.
Like terms. Now be careful here. I have minus 174.
So it's a
But
negative.
Yeah. So let's take that negative 174 or minus 174 plus
Negative
28.
Negative
126.
126.
Negative 126.
46.
Oh, 146. Okay, sorry. See, guys, I don't know what is wrong with my hearing. I have to make everybody repeat themselves so many times. Yeah, negative 146 when I combine. So I'll bring down x minus 146 equals 90. And now what?
Add
X
46.
Yeah. Oh, no, I got the equals. Okay, x equals.
What are we here?
236.
236.
Yeah.
That's crazy, but that's correct. That's correct. Now, you might be thinking, how does that make sense? How can we get 236, but this is only 90 degrees? Is that possible? Did we do something wrong?
No.
No, this isn't the angle, this is x. Okay, so if x goes here, when we plug it in, look at this. 236 minus 174, what is that angle really?
62 degrees.
62 degrees, that makes more sense. So what we did is I took that x, 236 minus 174, and this angle, let's see, 236. Yeah, it's 62 degrees. There we go.
And what about with 217?
Now let's do it the way with the 270. So technically with number 6, if we want, we don't even need to use the 270 because we just found x and we can be done. So this is just extra information. Sometimes that happens. They just give you extra things you don't need. But let's show another way that you could do this using the 270. So let me move that. If I wanted to include all 3 angles, instead of them being equal to 90, what would they be equal to? All 3 angles together.
360.
Yes, 360. They go all the way around a full circle. So, what equation could I write using all 3?
X minus 74 minus 28 plus 270.
Yes, x minus 174 plus the 28 plus 270.
That's what I do.
Good. Equals 360. That's correct as well. And we should get the same answer. Let's double check.
This one is easy.
This one's easy?
Yeah.
Good. Good. So we'll combine our like terms again. Negative 174 plus 28 plus 270. And I got positive 124. Let me know if you guys get the same. You get that? Good. So all 3 gives us x plus 124. Bring down equals 360.
Minus.
Minus. Good. 124.
We should.
We get the same answer, don't we?
Yeah.
Yeah. We get 236 again. What?
2 times.
So there's lots of ways to solve these problems. You're going to get the same answer as long as you do it correctly. That's the key. We got to be careful. But this is another way. It worked both times. Both times.
Okay, what did you just do to get that 124?
So to get 124, we took negative 174.
Oh, okay,
plus-
negative.
Ah,
Okay.
yeah, that negative.
Okay, I didn't put the negative in.
Yes, we have to be so careful with negatives. And then we just added the 28 and the 270. I know, sorry, I wrote that a little sloppy. That's my bad, guys.
There we go.
Stop apologizing. You apologize so much this morning.
There you go. As Charles say, winning.
Winning.
Mm-hmm.
Oh,
All right. So, looking at this worksheet, can I move this away?
Yeah.
Okay, perfect. Let's see what else we can do. Number 3? Okay. Can we do number 3? Do we know how to do this one yet? We do. How?
You do the highlighter where you color it in.
Yes, guys, what kind of lines are these? Parallel lines. I know it's not red, but that's what these are. Parallel lines. And so we can use a special trick for these, the circles. Let me get
Look, I do this like I've been trying to.
a highlighter here.
Look, I
Circle time.
Do like I'm gonna do circles, right? Circle my 4. Circle my other 4. Remember?
Yes.
I do now.
Yeah. So
It in.
what are we thinking here? What should I color?
180.
180. Where's 180?
Color in the 5x plus 4 and the 59.
Okay, so look,
And the
In
ones
this-
across from
in this circle, I decided, so there's 1, 2, 3, 4 angles. We did the bottom left angle here,
Yeah.
and the one across from it is equal. On the top circle, we need to color the same ones, bottom left and top right. So, you remember the rule?
Yeah.
So are these angles equal, or do they add up to 180?
Equal.
They're equal. Yes,
They
yes. They're equal. They're the same color, so they're equal. You can also use that little piece of lamination and trace the angle and move it down and see they're the same size. I don't know what mine went, but do that.
Yeah.
So what equation would I write? Uh-huh.
59.
Yes. 5x plus 4 equal 59. They're equal to each other. They're the same. That's okay. That's
I will
okay.
count that. Should put that in there.
Now, if they were different colors, I'm gonna just color the rest in just so that we can see the difference a little better. If we had different color angles, they wouldn't. Then it would be add them equal to 180.
Yeah.
Okay. So let's solve this. The line through my equal sign. Good, -4 both sides. 5x equals 55.
Then you divide it by 5.
Yeah, divide by 5, and x equals 11. Yes. X equals 11. Very good. Very, very good. Okay, what else can we do? What other numbers can we do?
I got a decimal for number 5.
For number 5, you got a decimal. So tell me, how did you solve number 5?
I had it equal to 180.
Ooh, equal to 180. So,
They would equal each other.
Okay, so let's think about this. there are a couple of hints that I actually gave you. Just like in number 3, I didn't point it out, but I put one arc on both angles. That means they're equal also. Over here, just like how on the parallel line angles, if they're across from each other, they're equal. These angles are across from each other, so they're equal. So we would only go set them equal to 180 if, for example, there was an angle here, like that would be A and that would be B. Those would equal 180 because they make a straight line. But we don't know if these make a straight line. They're just across from each other, right? So these are equal to each other. Does that make sense?
Yeah.
Okay. So what equation can I write?
X plus 10 equal to X plus 12.
Good. 3x plus 10 equals 2x plus 12.
X2.
X is 2?
Yeah.
Okay, let's see. And what can I do here?
2x.
Get rid of the 2x? Okay, minus 2x. Minus 2x. Let's see.
Plus
3x minus 2x is x. Bring down plus 10 equals. So bring down 12.
Minus 10 on each side.
Good, minus 10. Minus 10.
X equals 2.
X equals 2. Good. Look at all these things we can do. We didn't even realize we could do them. We've learned a lot. Good. Sing it.
Sing.
All right. What else can we do?
Number 2.
Number 2? We can do number 2.
Yeah.
Does anyone still need to see this, or can I move it?
Yeah.
You can move? Okay. All right. Number 2.
Yeah.
How do I do that?
Those are equal.
They're equal.
No,
What?
I was throwing you off.
Oh, yeah. Okay, so how are they related? How are they related?
I think you can flat.
Yes, we have a flat line, a flat angle.
We're gonna add up to 180.
Yes. These make a half circle.
180.
There's a flat line. They are going to add up to 180. So what equation can I write?
X plus 12.
Mm-hmm.
It's 12 or 2.
It's 12. 12.
12
I know
plus
that
140.
one is kind of wiggly. X plus 12
Plus 145
plus 145
equal 180.
equal 180.
Your like terms
Add my like terms.
makes it 157.
Good. So x plus 157 equals 180.
Give me 157.
Yes. You guys are so smart. Minus 157.
When you get 23.
Oh my goodness. Yes. X equals. Yeah, 23. Good.
Let me see number.
Which one?
Number.
Number 1. Awesome. That one here.
Let me
So
360 is plus B.
The 360? Yeah, A plus B is 360. So this one for number 1 was 360 because it had a full circle. This X was a big angle, great big angle. That's 360 degrees. So when I add those two together, they equal 360.
Do you listen to Charlie XCX?
I don't know, I might.
She has some called 360 and I'm trying to say it plays it in my head.
Now I need to look it up.
It is like club DJ EDM hit by this.
Funny, okay, I'm gonna look it up after this. Right. Can we do number 4?
Yeah.
Yeah.
We can.
Can we?
I don't remember this one.
I don't know. You got a decimal for that one?
Yes,
Okay,
I
let's
did.
see. Let's see. Number 4. How do we do it?
I told 4x plus 1
Mm-hmm.
plus x plus 40
Mm-hmm.
equals 90.
Equals 90. Yeah. Perfect.
Why
Perfect.
have number
So-
decimal?
So you got a decimal. Let's check the work. I can't remember what the answer is. But everybody, you see how this right here is 180, right? But I already know that this is 90.
Yes.
So what does these together have to be?
90.
Also 90. Yes, yes. So just like with number 6, how we saw that there was a 90 degree, we can ignore the rest of this picture and just look at the 90. So this plus that equals 90.
Oh,
Yeah.
I missed one.
Uh-oh. That might be why. Before I start writing this out, does that make sense to everybody?
Yes.
Do we get why? Okay. Yes? Yes?
It should be fine.
All right, so let's write the equation. We have 4x plus 1
Plus 14.
plus,
X.
good, x plus 14 equals 90. Good. Combine like terms.
5x plus 15.
Yes, 4x plus x is 5x. 1 plus 14 is 15
Equals 90.
equals 90.
So you got 15.
Subtract 15.
5x equals 75.
Uh-uh.
Then divide 5. So it's x equals 15.
Come on, Jose, come on.
Yes.
Winning, yeah.
Jose has to go
Jose,
clap
honey.
it. Clap it.
Oh, it's so good, you guys. Good. All right.
I think we're ready for the quiz.
Who?
Y'all might
You must be yourself.
All right, guys, we have done some excellent work today. Excellent, excellent work. I think you guys deserve to enjoy your weekend. Okay, so that's all today. Please don't forget day 1, day 2, day 3 exit tickets due tomorrow. If you're not sure what you still need to do, you can come and check in with me. But you guys are free to go. You can stay if you want. If you want to catch up on stuff or if you need help from me, please stay. However, if you feel good, you're all caught up, you are free to go. Adios.
Adios.